Hey guys, what is going on? Welcome back to another video. In this video, we're going to be covering how to set up the gear mesh in your radio-controlled vehicle. We're going to use an alternate method to what we've previously covered. In this video, we're going to talk specifically about using the Backlash method. Now, before we dive into an example where we're going to go and set the gear mesh on this specific radio-controlled vehicle, I first want to talk about what Backlash actually represents for us. The best way to describe Backlash is to use a very simple example that we can all relate to using my hands and also fingers. Now, if my hands represent the spur gear and the pinion gear and the fingers on my hands represent the teeth, I can go ahead and mesh these together. And what you'll notice as I bring my hands together and start meshing my fingers together like teeth on a gear, you'll see that there's big gaps in between my fingers. I can rotate one of my hands and go through quite a distance until I contact the next set of fingers on my other hand. Now, it is exactly this distance of wasted motion that Backlash represents. Backlash, by definition, is the wasted motion in a mechanical system when you go and drive an input and you don't get any result out of your output. There's no work done on your output side. The next question that you might be asking is, well, why do we have this backlash in our transmissions? What is its purpose? Why is it there? And how do we eliminate it? Well, it actually has a very good reason within our radio-controlled transmissions. We don't want to fully eliminate backlash within our system. The main reason as to why backlash is there is because it ends up eating up all the differences that we have with tolerancing within our components. There's quite a bit of tolerance that is built and stacked up within our gears, and backlash allows us to get away with not having a perfect part. And this will allow us to operate our transmission both effectively, efficiently, and with reduced amounts of wear. Now, there's a couple things that would affect the amount of backlash that you'd have to have in a system. And one of them is the amount of runout that you have within your gear. Now, if you've ever seen one of those gears where you're rotating it and you can see that the gear's kind of doing this, that's going to add to the amount of backlash we have in our system. Another area is the actual design of the teeth versus how it is manufactured. If it's manufactured and comes out with a significant tolerance for gears, we would have to go and up the amount of backlash that we have within our system. That's going to allow that gear that's somewhat out of tolerance to better mesh with the system and not cause any significant binding with the transmission. Now, there's a whole bunch of other factors that also come into play and affect the amount of backlash. It all has to do with the amount of tolerancing that is within your system. Now, there's two ways that we can control backlash. One of them is the design of the gear. That's not up to us. So what can we control? Well, we can control the amount of distance between our gears. If we were to go back to the example, if I bury the gears in tight, I'm eliminating backlash and I'm not allowing things to move. That is not necessarily a good situation. At the same rate, if I go back the amount of distance between my gear, I can have a significant amount of backlash now in the teeth of my gears. That is also not so good. We're right on the verge of stripping the teeth out. So there is a happy medium that we're looking for when we go and mesh the system. Now, one thing I do have to mention before we dive into there, quick point, if you do not know if your mesh is too tight or too loose, you want to err on the too tight side. Now, there's a big reason as to why you want to do that. When it comes to gear mesh and you set the gear mesh too loose so you're riding on the edge of the teeth, there's not going to be a lot of signs and symptoms that suggest to you that it's too loose. You're going to have a lot or significant amounts of backlash. However, you're not going to have the other signs that come with a gear mesh that is too loose. What could happen very quickly to you is you load up that transmission with a lot of power under heavy acceleration and you strip the teeth of those gears clean right off. Now you have to replace those gears. Nylon gears tend to be significantly cheaper, but if you do have a metal gear, that's going to cost you a little bit more. And aside from the cost, it's going to be effort, work, and it's unnecessary. A transmission that is set too tight will have a lot of whining type noise that should be somewhat obvious to you when you're running it. It will be more obvious to you if you've ran the vehicle and had the gear mesh set up correctly, and then you go and run the vehicle with a mesh that's set up too tight. You will hear it right away if you're very familiar with the sounds that your vehicle makes. With that being said, let's dive into the example and set our gear mesh based on Backlash. Alright guys, so right now we're taking a look at the transmission in this particular vehicle. We're looking at the motor and how it meshes up against our spur gear. The first thing that we want to do is just back the motor completely off. So this screw is loose. I can now shift the motor around here, backing it right off. So I can see this is now freewheeling. And what I'm going to do first is I'm going to bury that pinion gear right into the spur. So I make sure it meshes, and then I press up against it nice and firmly, and then I'm going to tighten it just to show you exactly what this looks like, sounds like, and so forth. So it's somewhat tight. That is really tight. It's hard to move. You can feel it binding in certain areas, and then it loosens up, and then it's loose right here, but then it starts binding up again, especially in this area right here. And then it loosens up, and then it starts binding again. So it's really tight. This would be where there is essentially zero backlash. I can't feel any sort of movement. I'm trying to push the spur gear around and I don't get any motion there. What I'll do is I'll now go to the opposite extreme. So I'll loosen it back off and I'll pull the motor away. And I'm listening for the point in which my pinion gear just starts to touch. So I'm going to push it slowly in until I hear that contact. And there it is. I can hear that now. It's just about to touch. So the point from right here to where we just were is the interacting point between those two gears. It's where those gears begin to mesh, and then our backlash is fully consumed. What I want to do is I want to find the place in between there that is going to be the optimum point for us. So what I'm going to do now is, now I know that is the point, I can push it in and you can see the amount of travel that I have to play with. It's actually quite a bit. I want to be buried as far as possible, but I don't want to have and experience any binding or noise. So I'm going all the way in, and now I'm just going to back off a small amount. What I'll do from that point is I'll tighten it and show you what we end up getting. So from this point, I should now be able to feel backlash because I've backed it up a little bit. I tried to go around 100% of the way in, and then I backed out 20% to give myself a small amount of backlash. So here you can see the gear moving. You can also hear a little bit of noise, but we know that it is based on our position of where the gears start to touch and then where they finish up. I know I'm about 80%, maybe even a little bit more. The percentage is not really relevant. What is relevant to us is where we end up here and what kind of mesh we have. So we can't see the mesh, but we can definitely hear it. We know that we got a small amount of backlash. Now we're going to rotate the motor. I don't hear any binding, any extra noise than what I would typically see. Everything looks good in this position. So right now, full revolution. You want to make sure you go through a full revolution, and the reason why you want to do that is because your gear, like we said, is not perfect. It can be out of shape in a small area where it binds up, and if that does happen, you may want to either do one of two things. Leave it as is and it'll wear in that one position, or you can back it out. It really is dependent on how much you'd have to back it out. I don't ever like to go and back my gears out too far so that they can end up stripping. More than likely, I will choose the path of just allowing it to wear in that one spot, as long as it doesn't take too many runs. Within a couple runs or so, it should be worn right in. So that is exactly how you set it up using the backlash method. Right there, you can see we got a good amount of backlash, a little bit there. And our gear mesh is quite tight enough to allow the power to transfer without stripping the teeth out. And there you have it. If you enjoyed the video, smash that like button for me, and don't forget to hit that subscribe button so that I can see you in that next video. Thanks a lot for watching, and I'll see you next Monday.